Welcome back. This video production is brought to you by
The Mole.
Mole, 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 mole.
I think that movie's older than most of you, so moving on. Guys, what is a mole? Mole is a small furry rodent, lives underground, has poor eyesight, and the mole that we're going to use in chemistry is entirely different. A mole is actually just a quantifier. So if I was to say that I have a mole of something, that means that I have this big number, 6.02 times 10 to the 23 of that thing. That's kind of crazy. We use this for very, very small things that we have very large numbers of because, well, scientific notation sucks. It would be a lot easier just to say, I got a mole.
Okay, so if we start talking about the mole, we can start making comparison to common terms we use around the house. So if you're talking about a dozen friends, how many friends do you have?
Well, a dozen's a quantifier that means 12, so a dozen friends would be 12 friends. 4 dozen pennies, how would you figure out what you have? You take your 12 and you multiply it by 4 to say that you have 48 pennies. Is it possible to have portions of a dozen? Yeah. Absolutely.
If you have 2.5 dozen warts, how many warts do you have? Again, you times 2.5 by 12 to give you 30.
And then the last one.
If you have 0.125 dozen teachers, how many teachers would you have?
1.5. This would be much better if there wasn't 2 of us doing this. Now this seems like an insult. Apparently now we're only actually 1.5 people.
So quantifying the mole. Okay, we can do the same thing with the mole. 1 mole of rice is 6.02 times 10 to the 23rd grains of rice. 2 moles of carbon atoms is 1.204 times 10 to the 24 carbon atoms.
Which is really just 2 times that mole number. And we can even do 0.5 of a mole. 0.5 of a mole would be just taking that 6.02 and multiplying it by.
And you guys can take a look at this too. This number is way more complex than this one. Okay, that's strictly why chemists use the mole is just to package up, okay, large amounts of something.
So, chemical reactions, why are we going to do this? Well, when we talk about chemical reactions, when we've done balancing, we always looked at the number of atoms in a molecule having the ability to change. We're building new molecules. However, conservation of mass says atoms must be the same before and after. So for reactions, if we want to compare masses, masses aren't always valid. 2 magnesium, well, if you remember doing models, magnesium is really small. It has a mass of only like 24 AMUs. If we were to look at a uranium has a mass of like 238. So these atoms are not the same size. If we look at the mass, we don't actually have the same number of atoms in 2 grams.
Okay, so if we talk about reactions taking place, which is a lot easier, Mr. Awesome Teach is doing a reaction with 2.35 times 10 to the 23 molecules of hydrochloric acid, okay, with 1.94 times 10 to the 22 atoms of magnesium. Okay, it's a lot easier when you're starting to talk about that already. I'm stressing to say those large numbers. Okay, wouldn't it be easier to say 0.391 moles of hydrochloric acid with 0.0323 moles of magnesium? Again, it's just more of a convenience.
You guys already know this back when we were in physics. No one likes scientific notation.
Absolutely not.
If we can get away without using scientific notation, that would be great.
Okay, if this is confusing, don't worry. With time and practice, like everything in chemistry, things get easier. But here's the bottom line. When we talk about 2 things reacting, we use moles. Not their masses, not their volumes, just moles. So let's put them to work.
Let's put them to work in a way that we'll actually use them. In large quantities, we can make averages about the mass of an item. So when we looked at the periodic table and we were trying to find masses of things, we would take a number for magnesium like 24.31 and we would round it down to 24. However, the actual number is 24.31. What that represents is a molar mass. If I have 1 mole of magnesium, it has a mass of 24.31 grams.
Okay, again, you may remember back to physics, we can write this as 24.31 grams per 1 mole. Okay, it makes our ratio a little bit easier later on.
So, how do we find the molar mass of species? Well, first off, we're going to find the molar mass of any atoms that might be present. Then we're going to multiply it by the actual number of atoms that are present. So, first example, we'll start things off nice and easy. What's the molar mass of sodium? You look on your periodic table. You find that periodic table, you find sodium, it's over on the left, it's in group 1. It has a molar mass of 22.99 grams per mole. Now, if I was to look at sodium as a chemical symbol, sodium, is he allowed to exist by himself? Yes. So, the molar mass of sodium is 22.99 grams per mole. I don't need to worry about multiplying anything because there's only one sodium. What happens when we get to something like the molar mass of magnesium? Well, as I just said, if you look on the periodic table, it says that it's 24.31 grams per mole.
Can it exist by itself, Mr. McLeod?
It can. There's some things that you have to remember can't exist by themselves. They'll be tricky. And then there's compounds, like carbon monoxide.
So when we write out carbon monoxide, as we think back to naming, we reminisce on our good time and naming and nomenclature, we end up coming up with a formula of CO. Carbon, one oxygen. Okay, now we have to look at our periodic table, and we take a look at what carbon has. It's 12.01 grams per mole, and oxygen is 16.00 grams per mole. Oh,
Now,
that's...
how many carbons do you have? Just one. How many oxygens do you have? Just one.
So we don't need to multiply it. All we need to do now is we just add these two numbers together to give us our total molar mass. Okay? Or if you're a normal person, you can go like this and just kind of add them like that. Whatever. Okay? So what we end up seeing here is a total of 28.01 grams per mole.
Awesome.
Mole.
Okay, next one. What's the molar mass of nitrogen? Now, this is great because this is one of those ones that gets a little bit tricky.
This is a great, Mr. McLeod. This is a great.
You're a jerk. Now, nitrogen. By himself, he has a mass of 14 try to remember periodic table since I don't have one present. I think it's 14.01 grams per mole. However, nitrogen does not show up by himself. He actually shows up as N2. So, if nitrogen shows up as N2, what that actually means is I need to take 2 times 14.01 grams per mole. This means that the nitrogen actually has a mass of 28.02 grams per mole. So even though we had to do a little bit of multiplication, it's still pretty quick to find the molar mass of our molecular elements. The last one, strontium chloride.
Okay, if we take a look at the formula for strontium chloride, okay, we see SrCl2. Okay, now we have several components here. We have 3 total atoms. Okay, we would just break it up. So now we have strontium, which has a molar mass of 87.62. Okay, and chlorine, we would have 2 chlorine. So we go 2 times 35.45 grams per mole. Oh, okay. So what we get for an answer there is 2 times 35.45 is 70.90 grams per mole. Okay, and then we would take and we would add our 87. So our next step would just be 87.62 plus 70.9 gives us a total answer of, and we end up finishing with an answer of 158.52. Yay! Grams per mole. Don't forget the units, guys.
Now, if you wanted to practice this again later, you could go back to before we wrote all this. You could try a couple of these out because then there'll be the showing of the work there. And then there's actually a nice little, like, typed proper, there is all the molar masses. Now, for a little bit of a challenge, guys, here's your chance. Take this. Pause the video. After you've paused the video, go actually find the molar mass of these things. Then, when you start the video again, we'll show you the molar masses of these species. Bear in mind, we need to be really careful with things like polyatomics, how we use our brackets, and making sure that we are tracking exactly how many of an atom are present. Okay. You paused it and you've worked on it, right? You're not just sitting there waiting for this to keep going? Okay, well, here come the answers.
All right,
so,
all right, here we go. Oh. Yep. Hey!
Okay. Ladies and gentlemen, we're not going to work through all of those right now. If you had a problem with any one of those, put a big star next to it on the sheet of paper that you were working on. bring it into class, talk to us, talk to your classmates. Chances are pretty good you are not the only one to make a mistake. We chose these 4 because these are 4 that students specifically struggle with.
Okay, so conversions between mass and moles, okay? Again, we obviously know that molar mass is our conversion factor between mass and moles. It has both the grams and the moles in it. This is a junction where many people prefer formulas. However, formulas suck. Okay, unless you have 4 variables at least. Okay, if you want to go to Chem 20 and you want to move on in chemistry, you need to know unit analysis. And we've talked about unit analysis in physics and significant digits and unit conversions. We need to carry that forward.
And it can actually help you be a faster student when you're working on this stuff. So, keys to unit analysis, make sure you know this. Numbers with 2 units, like grams per mole, are actually ratios. Never start with your ratios. Maybe in Chem 30 when you get better at this, absolutely. But for now, don't start with a ratio. Start with things that only have 1 unit. Make sure your unit is on top, and when it's on top, make sure it's multiplied by the same unit on the bottom to cancel it out. And it's reverse. If you had a unit on the bottom that you're trying to cancel out, you would put something on top. Essentially, guys, Mr. Rayner doesn't like my math word too much, but this is using math in a science class. It's not normal math skills, they are like science math skills. So let's try one. Little Tony decides that he has 4,000 moles of iron to make a suit. Tony, suit.
Tony.
Interesting. All right, Tony Stark. Now, no copyright infringements intended. How do we start out unit analysis? Guys, we start with what we know. We have 4,000 moles. I'm going to multiply that by moles on the bottom, because I don't want moles. The question has asked me what the mass is. So now I can cross moles out. Pull that back over here. I can cross that out. I can put mass on top. But this is only going to work if I have a conversion between moles and mass of Fe, iron. Now, iron can show up by himself, so I can go to the periodic table and I can just read it out as 55.85 grams per mole. But which side do I put the 55.85 on? Guys, molar mass is always the number of grams per 1 mole. Now, the table says that was that looks like a 6, 55.85 grams. So now if I pick up my calculator, I take 4,000 and I multiply it by 55.85. This tells me that the mass of iron that I have is, clicking away on a calculator, 223,400 grams. Now, little side note, whenever you guys are calculating these things, your answer does not have to stay in grams. If you want it to stay in grams, you can go to scientific notation. This would be 4 sig digs here, 4 sig digs here. This would be 4 sig digs. I could call this 2.234 times 10 to the 1, 2, 3, 4, 5s in terms of grams. Another sloppy 5. Or, if you don't like leaving it in grams, this is 223.4 kilograms. Sounds like a pretty heavy suit. He's going to need a pretty good energy source to keep that thing moving.
Little Sally has 500 grams of tin, so we're just going to work the other way this time. Okay, so again, in the question, we're given a mass of 500 grams, and that's where we're going to start. 500 grams. Okay, we know, okay, you got to be very careful here because we see 2 letters. Obviously, this says tin, but it's not tin. Okay, it's supposed to be a little bit of a trick here. Okay, so we have titanium and nitrogen. Okay, so we need to find the molar mass of this first. So if we're looking for molar mass, okay, we have titanium,
which is 47.87.
47.87 grams per mole. Okay, and we would add that to our nitrogen, which is 14.01, and we get an answer of 61.88 grams per mole. Now, we're going to use this, okay, in our unit analysis, just like before. It's a ratio. It's going to help us convert this into the units that we want, because we're looking for how many moles. Okay, so again, we're going to draw our ratio. We're trying to get rid of grams, so we're going to put grams in the bottom. Okay, and we're trying to get 2 moles. Okay, so we see grams cancel. Okay, now we need to fill in where the number goes. And just like Mr. McLeod said before, the number always follows the grams. It's 61.88 grams per 1 mole. So we see 61 on the bottom. Just like we did in physics, to solve this problem, we go with 500 divided by 61.88 to give us an answer of, to get an answer of 8.08 moles.
Now, guys, you can totally make the reference here that you can just leave this in moles. You don't have to do scientific notation. You don't have to do unit conversion. Just leave it as this number. It's nice and it's easy.
Perfect.
Now, you can all read. Your understanding of the mole this year is kind of goofy because in grade 10 we don't use it a whole bunch. Start with the molar masses. Start with converting molar masses. As a chemist, eventually you will use the mole so much that you'll start to understand it a lot better. If you don't carry on in chemistry, that's okay. The mole was just a quantifier. Treat it like a dozen. You will be just fine. As a final note, everything in chemistry typically comes back to the mole.